Hello, my name is Hernández-Vaquero, and in today's tutorial, we are going to dive into the fascinating world of TF-IDF vectorization. This technique is widely used in text analysis and natural language processing to transform text data into numerical representations, making it easier to perform tasks like text classification, clustering, and similarity analysis. In this step-by-step guide, I'll walk you through how to implement a TF-IDF vectorizer in Python using a real-world dataset of job titles. We'll explore how to preprocess the data, transform it into TF-IDF vectors, and compute cosine similarity to recommend similar job titles based on a user's input. Whether you are just starting with NLP or looking to enhance your text analysis skills, this tutorial will help you understand how TF-IDF works and how to apply it into your own projects. Be sure to check out the code on my GitHub repository, which you can find at the link shown on the screen. There, you can download the code, follow along, and even modify it for your own use. Let's get started. The first step is to set up your environment. Before we dive into the code, make sure you have the necessary libraries installed. For this tutorial, we'll be using Pandas for handling data, Scikit-Learn for implementing the TF-IDF Vectorizer, and NumPy for numerical operations. To install these libraries, run the command shown in the screen. Step 2. Import the required libraries. Once the environment is set up, import the libraries you'll be using in your Python script. Here's what each library does. Pandas manages your dataset and handles data frames. TF-IDF Vectorizer converts text data into numerical vectors using the TF-IDF algorithm. And cosine similarity measures the similarity between vectors. Next, load your dataset. In this case, we'll use a sample dataset that contains job titles, but you can modify this to suit your own data. Here we assume that you have a CSV file with job titles. If you are using a different format, adjust the read CSV method accordingly. The dataset should at least have a column for job titles. Step 4 is to inspect your data. Before proceeding, it's important to inspect the first few rows of your dataset to confirm it has loaded correctly. This will display the first 5 rows of the dataset, giving you an overview of the data structure. You can check the column names, data types, and initial entries. As an optional step, you can add a new job title. If you want to add a new job title for comparison, you can create a new row in the dataset. This will represent the job title you want to compare against the others in your dataset. Here, we are adding a new job title with placeholder values for other columns. Step 6 is to initialize the TF-IDF Vectorizer. This object will transform the job titles into numerical vectors based on the term frequency and inverse document frequency of the words. The vectorizer will automatically learn the vocabulary from your text data and assign a weight to each term based on its importance in the dataset. Step 7 is to fit the vectorizer to the dataset. With the vectorizer initialized, it's time to feed it to the job title column of the dataset. This step transforms the job titles into TF-IDF vectors, where each vector represents a job title as a weighted sum of terms. This will create a sparse matrix X, where each row corresponds to a job title and each column represents a unique word in the vocabulary. Step 8 is to transform the new job title. To integrate the new job title into the analysis, you need to transform it using the same vectorizer. This ensures that the new title fits into the same feature space as the original dataset. This step converts the new job title into a TF-IDF vector, allowing you to compare it to the job titles already in the dataset. Step 9, get the feature names. Once the vectorizer has processed the data, you can retrieve the list of unique features or words learned by the vectorizer. This will show you all the terms that have been extracted from the job title column. This will output a list of all the unique words or tokens used to create the vectors in the matrix X. Step 10. Check the dimensions of the TF-IDF matrices. It's important to verify the dimensions of both the original and transformed matrices to ensure they match the expected format. The output will give you the number of rows and columns in each matrix. The number of rows corresponds to the number of job titles. The number of columns corresponds to the number of unique words in the vocabulary. The next step is to compute cosine similarity. Now that you have the TF-IDF vectors for both the existing job titles and the new job title, the next step is to compute the cosine similarity between the vectors. This metric measures the angle between two vectors and gives us a similarity score. The result is a matrix where each value represents the cosine similarity between the new job title and a job title from the original dataset. Step 12. Review the cosine similarity matrix. To get a better understanding of the results, you can print out the cosine similarity scores. Each entry in this matrix tells you how similar the new job title is to each job title in the dataset. The higher the value, the more similar the job titles are. Step 13 is to retrieve the top recommendations. Now, let's define a function to retrieve the most similar job titles based on the cosine similarity scores. We'll sort the scores in descending order and select the top 10 most similar titles. This function will return the top 10 most similar job titles along with their locations, fit, and the calculated similarity scores. Finally, we will display the recommendations. We can call the getRecommendations function with the new job title and print the top 10 recommendations. This will display the most similar job titles along with their similarity scores and other relevant details. Thank you so much for watching this tutorial on TF-IDF vectorization. I hope you found it helpful and that it gave you valuable insights into text analysis and how to work with TF-IDF in Python. If you enjoy the content and want to learn more about text processing techniques, make sure to hit the subscribe button and stay tuned for more tutorials coming your way. In our next video, we'll be diving into word-to-vec, another powerful technique for converting text into numerical representations. If you're interested in exploring word embeddings and understanding how word-to-vec works to capture the meaning of words, you won't want to miss it. Once again, thank you for your support. Don't forget to leave a like if you found the tutorial helpful, and feel free to drop any questions or suggestions in the comments below. See you in the next video.